In our last video, we talked about the relationship between a drop in head in an aquifer and the amount of water that's released in qualitative terms. We now want to quantify this relationship and use a couple of terms that exist in the field of hydrogeology to describe this quantitatively. The first term is called the specific storage. And it's a property of an aquifer. And it's defined as the volume of water released or gained, but we'll just say released, per volume of aquifer considered per the drop in head. So it's the way that I find is easiest to think about this is just imagine that there's maybe like a cubic meter of the aquifer that you're considering. So it's a box with unit dimensions, 1 meter on all sides. And you're causing a 1 meter head drop here, a unit head drop. What is the volume of water that comes out of this? That is the definition of the specific storage. And it's going to have dimensions of, let's see, volume divided by volume, that's dimensionless, divided by a change in head. Head has units of length. And so our dimensions are going to be 1 over length for the specific storage. So this is sort of an intrinsic property of the aquifer. It doesn't matter how big the aquifer is. We commonly, though, reference this specific storage term to a dimensionless term called storativity that takes into account how thick an aquifer is. So this term storativity which is typically denoted with the symbol capital S, and I should say that this one here is capital S subscript S, is defined as the volume of water released per, instead of the volume of the aquifer, we're going to do the surface area per the drop in head. And a quick units check is volume divided by an area times a length. This term is going to be dimensionless. And the way that I think about this is now you're considering a surface area, which let's say it's a unit surface area, so it's a meter squared, it's 1 meter on either side. And you're considering the entire thickness here. So it's going down to wherever the bottom of the aquifer is. And if we were to say that the saturated thickness of this thing is B, the relationship between specific storage and storativity is going to be that the storativity is equal to the specific storage times the saturated thickness of the aquifer. And so there's some similarity here between this relationship and the relationship between hydraulic conductivity and transmissivity. Hydraulic conductivity is this intrinsic part when you just consider any little part of the aquifer. The transmissivity is taking into account the integrated thickness of the aquifer, just like storativity is as well. So again, this is how much water is going to come out of this column of unit surface area for a unit drop in head in the aquifer.